All right, cool. So yeah, good morning again. All right, so PA3 is graded and feedback is given to you. And PA3 was good work. Saw lots of good solutions and really good coding styles. So keep up with the commenting and describing the methods and the classes and so on and so forth. Plus, indenting and stylizing your code. That's all looking really good. All right, so I want to keep talking about PA4 today. Any questions up front before I just kind of jump into it? All right, I will post this up on Canvas later today. I don't know if this is going to be helpful to people or not, but this is a one-page synopsis I made of interacting with graphical elements in general. Right, this is not just for Java or for PA4 or something. This is kind of a general way to think about viewing a screen, whether you're playing tic-tac-toe or battleship or chess or dots or something else. And let me just show you what's on here. And like I say, I'll post this and we'll develop this today. But imagine a display area with a certain width and a certain height, right, called width and height. And imagine you want to picture this as being broken up into a number of cells or boxes. Okay, and I'm going to set some variables. Number of rows is how many rows we have. Okay, so rows run horizontally. And number of columns is the number of up and down, right, columns that we have. Each column runs vertically. So in this case, I've got 7 rows going up and down, and I've got 5 columns going across. Okay, almost always, and absolutely always for me, unless I mess up, when I refer to the index of something in a two-dimensional array, I do row, comma, column. Okay, so this is cell 1, comma 3. It means go down to row 1 and go over to column 3. So this is column 0, 1, 2, 3. Okay, this up here, this element right here is row 0, 1, 2, 3, column 0, 1, 2. So this is cell 3, comma 2. And this is backwards from x, y coordinates. When we do x, comma, y, x goes across, y goes up and down. But for row column, I do what's called row major, right? So the row is the first dimension and the column is the second. And I will be, absolutely consistent about that unless I mess up. So that's the first thing to keep straight. Now, if the height of this whole area is height, and if my number of rows is num rows, then I can find the height of this individual cell, and it's just going to be height divided by number of rows. And the width of one cell is going to be the total width of the whole area divided by the number of columns. Okay, so that's a useful pair of formulas. And this is nice, if you're making a playing area that's resizable. When you drag a corner of the frame, you can have code called that you can use calls to find the new height and width, and then you can figure out what the height of each cell is, what the width of each cell is, and so on. All right, if you are at a particular cell bracket, row, comma, column, how do you find the coordinates of the corners? Upper left corner, assuming that the coordinates of this very upper left corner are 0, 0, right, which they are. Then for a cell in column col, the x-coordinate is just column number times cell width. Okay. Right, because each one of these is cell width, so if this is 0, this is 1 times cell width, this is 2 times cell width, 3 times cell width, and so on. So this cell, the column number is 2, right, so 0, cell width, 2 times cell width, that's the x-coordinate of the upper left corner. And similarly, counting from the top, the y-coordinate of the upper left corner is just row number times cell height. Okay. So that's a useful pair of formulas. Okay, if we know the coordinates of the upper left corner, we can find all the other corners. Because if we take this x coordinate and we just add cell width, right, we get the x coordinate of this. So this point has coordinates x plus cell width comma y. This lower left corner has coordinates x comma y plus cell height, and the lower right is x plus cell width, y plus cell height. Okay, so if you know the total width and height, right, you can figure out the cell height and the cell width. Presumably you know the total number of rows and columns, and with those you can find the xy coordinates for the corners of whatever, you know, box, bracket, row, comma, column. All right, so that lets us go from this box coordinate system to the actual xy coordinate systems in which all of our graphics objects work. When you say draw a line, fill a rectangle, draw a string, the xy coordinates are the ones, you know, in the actual J-frame going from 0, 0 out to width -1, height -1. Okay, to go the other direction, suppose we have an xy coordinate and we want to know what box that corresponds to. Okay, so that's just a pair of integer divisions. If you take a point xy and you want to know what cell it corresponds to, the row number is just y divided by cell height, and the column number is just x divided by cell width. So let's do some examples, and we'll play with dots. So here's point 0, 0. And we'll suppose that these are each 50 by 50. Okay, but you know, if it was a general case, you would take the height and the width and divide by the number of rows and the number of columns, and you'd find the height. But you know, PA4, I said make them 50 by 50. So this point down here has coordinates 50, 0. This is 100, 0. This is 150, 0, and so on. This is 0, 50, 0, 100, 0, 150. This is 50, 50. And this is 150, 50, 100, and 100, 100, and so on. Okay, so finding the coordinates of the corners of these things, that's just plugging into the formula. Let's look at mouse clicks. Suppose somebody clicks their mouse right here, and let's say that this is, you know, 72, 65. Okay, we'd like to know that this is actually row 1, column 1, right? We'll take each of these divided by 50 and round down, and you're going to get 1, 1. If somebody were to click right here, and let's say this is the point 135, 75, right? Well, divide both by 50 and round down. This is going to be 2 point something. This is going to be 1 point something. That tells you this is row row and column. All right. So this is 2, and this is 1. This is the column. This is the row. So this is 1, 2. All right, what does this have to do with PA4? Well, you're going to pick up a mouse click. The first thing you're going to want to do is figure out what box the person clicked in. Okay, so they click, you're told that they clicked in 135, 75. You do the simple division, round down, and it'll tell you that they clicked in this box, 1, 2. Now, if you made a two-dimensional array of boxes, which we'll talk about today, you can do something like, you know, box B equals board row column, where row was this thing over 50 and column was, well, it's not this thing. Row is y over 50 and column is x over 50. All right, so getting to a particular row column is just this straight division, okay? So the other part of this is, how do you figure out which line they clicked closest to? So let's just blow up this example. And I'll use the same coordinates where they clicked on 135, 70. Well, that's right in the middle. I don't want to do that. But let's say they clicked at this was 100, this was 150, this was 50, this was 100. So let's say they clicked right here at like 135, 60. The two closest points to the cursor. Yes. So so you click right. Let me make this a little more exaggerated. Suppose you click right here, right? You're probably asking to draw this line, okay? If I click right here, I'm asking you to draw this line. If I click right here, I'm asking you to draw this line. If I get really close to over here, though, I'm probably asking for this line. Okay? If I clicked right here, I'm definitely asking for this line. And if I click right here, probably want this line. But, you know, if I click over here, I probably want this one. And if I click here, I probably mean that. So here's what seems to work pretty well to figure out which line the person is clicking on. Measure your distance to each of the four sides. And whichever distance is shortest, that's where they're clicking. So now if the person clicks right here, what do your distances look like? Well, if this is the shortest distance, they probably meant that line. And if they click right in the middle, they're being ambiguous, right? And guess what? These distances are going to be the same, right? 25 to each side. But you know, that's ambiguous. But if they're clicking, you know, right here, then clearly they wanted to select that line on the bottom, and this distance is far shorter than that, or that, or that. And I think that's what people do when they want to, you know, indicate where they want a line drawn. They're probably going to try to put it like, you know, right in the middle, right between these two things, and that distance is definitely going to be the shortest. Okay, so how do you figure out which distance is shortest? Just calculate your four distances. So suppose you know that the upper left corner has coordinates x0, y0. You could make it so that if two distances are plus or minus 5 of each other, nothing happens. Yeah, that's a really good idea. So yeah, someone just suggested you could set it up so that if, you know, all the distances are about the same, instead of just taking whichever one is closest, just don't do anything. Make sure that they actually get significantly closer to one edge. That would be a really nice embellishment. I like that. All right. Well, how do we figure out which edge they meant? So make two distances, right? Distance left. And distance left would be, let's say this is the point xy. Distance left would be what? It would be x minus x0. Distance right would be, well, this is x0 plus 50. This is y0 plus 50. I'll do full coordinates, comma y. This is x, y0 plus 50, and this is x0 plus 50, y0 plus 50. So this is distance left. Distance right is going to be x0 plus 50 minus x, right? This is x0 plus 50, this is x. So take that difference. Double check, if I add distance left and distance right, I get x minus x0 plus 50 minus x, I just get 50, right? Which is what I should get. How do you get the specific coordinates of the points? Which points? So the xy point comes from the mouse click. Okay, that's going to be passed to our mouse listener. The x0, y0 is going to come from here once you figure out what your row column is. So get the mouse click, use this to figure out your row and column, and then use this to figure out the xy of the upper left corner. Yeah, there's a math.abs that works on a variety of methods. And it's just a static method, so uppercase math. Alright, so here's the distance to the top. Here's the distance to the bottom. Yeah, it's nice having a whole math library at your disposal. And you don't even need to say like -lm anymore. You don't need to include anything or import anything. It's just uppercase math dot whatever your favorite math function is. Alright, so distance to the top is, remember, y increases as you move down, so it's going to be y minus y0. And distance bottom is going to be this lower coordinate, y0 plus 50 minus the y coordinate. Alright, so you can calculate these four, and, you know, 4 if statements. If d left is less than right, and d left is less than top, and d left is less than bottom, then they're asking to draw this line on the left. And if d right is less than left, and d right is less than top, and d right is less than bottom, then they're asking to draw the line on the right. Don't be afraid of long if statements. Okay, copy and paste and global replace will, you know, help you write them. And if you want to do this embellishment where you only require things to be like, you know, unambiguously close to an edge, so if d left plus 5 is less than d right, and d left plus 5 is less than d top, and d left plus 5 is less than d bottom, right, then we know that they're at least 5 closer to the left than they are to any other edge. So you can do things like that. Alright, so this kind of setup lets you figure out which edge they're next to, right? So they click, you figure out your row column, you figure out your upper left coordinates, and then you figure out which edge the person is clicking on. And now what do? You go through, you look at the box structure, right? And you say, if they're clicking on the left, is the left already set to true? If it is, there's already a line here. So, you know, flash the screen and say, hey, click somewhere that doesn't have a line yet, right? But if there's no line there, go ahead and set that to true. And then, as long as your column is not 0, take cell bracket row comma column minus 1, set the right to true. So board. And we do two-dimensional arrays like that. Right, but if column is 0, there is nothing to the left, so you don't need to set the right edge of another box. So it's a fair amount of code, but it is kind of brainless code once you've written the first version, right? The code to set the left you have to think about, but then the code to set the right, the top and the bottom is exactly the same thing. it's one of these things that you encounter a lot in this kind of program where, you know, you just change all your lefts to rights and all your minuses to plus and so on. But think about it while you're doing it. Don't just follow the pattern, but you should see a pattern. Okay. And that's kind of all you need for the mouse interaction part of this, right? Get the mouse click, find the row column, find the coordinates, figure out which line they're clicking on, make sure the line's not drawn, and if that's the case, go ahead and set the true flag, the edge flags appropriately. So board bracket R bracket C dot left equals true. And then if C is bigger than 0, do board row column -1. And then you've responded to the mouse click. So now what do? You call your thing that scours the board and looks to see if there's any new boxes, right? And maybe get a Boolean back from that to say, did I find a new box that was completed? And if you did, it's still going to be the same player's game. So if you do that and there's not a new box completed, change the player, right? So you can use a flag, player 1, which is true when it's player 1's turn and false when it's not. You can use an integer that bounces between 1 and 2 or 0 and 1 or whatever you like. You can use initials, whatever, but something to keep track of whose turn it is. All right, questions about this? I'll post this cheat sheet on Canvas later today for what it's worth. If it doesn't help you, don't worry about it. All right, so let me run through some other things. Let me talk about arrays. Alright, so here's a rectangle class. Here's a main method. I don't know what this is going to do. Going to do that because I used a lowercase r. All right, so basic object construction, right? Here's a rectangle of dimensions 2 by 3. All right, so let's make an array of these things. All right, so in Java, when we want to make an array, we can say something like rectangle bracket bracket. I'll just call it board. Okay, that declares an array of rectangles with no particular dimensions to it. Okay, so I can do something like this. Right, and that'll compile just fine. I'm not doing anything with this yet, so certainly if I try to do something like I try to print out the value of board bracket 0, right? Even the compiler can tell that's going to be a problem because, you know, I've never given a value to board bracket 0. Okay, so this is a declaration. We're declaring it, but with no specific dimension. To actually construct this array, right, this is where we malloc the space for the array itself. We can say board equals new rectangle bracket 8. Okay, so construct an array of 8 rects. Well, I can compile that, right? And when I try to run it, my board is null. Okay, if I try to do anything with that, if I tried to call, board 0 get height, I would get a null pointer exception. Okay, my toString method works, but anything else I would get a null pointer exception. So I've constructed an array of 8 rectangles, but with the very important realization that these rectangles don't yet exist. I've basically made something that refers to 8 rectangles. So board bracket 0, board bracket 7, those are all valid things to look at. But if I were to try to access board bracket 8, right, I'll get an index out of bounds exception. So it's like board is now so at this point, board is I don't know how to describe it. It's nothing, right? It's like integer I. I doesn't actually have a value yet. Okay. When I do this, board is 8 nulls. Right? It's this array that can hold 8 rectangles, but those 8 rectangles do not exist yet. Okay? So with arrays of objects, we have to do an extra step. We have to actually construct each of these rectangles. For example, let's construct each rectangle. Board bracket I equals new rectangle I comma I plus 2. Okay. Now I've actually constructed these rectangles, and so each of these things is, this is a 0 by 2, this is a 1 by 3, this is a 2 by 4, and so on. So we can construct these rectangles and then run through a loop and print them out. I knew that would happen. Right, and so there's our 8 rectangles. So arrays of objects always need sort of 2 steps. The first step is to, 3 steps if you count the declaration. After you declare it, 2 steps, you have to actually construct the array, and this is where you specify how many things it can hold. But if you don't actually construct each of those individual objects, they're just null. So typically somewhere you're going to go through and you're going to set an element of that array to be, in this case, a new rectangle. So if we're thinking of boxes and our game board being an 8 by 8 array of boxes, it's going to be exactly the same thing for 2 dimensions. Can you not just do the for loop? Which for loop? So yeah, this is actually doing the construction. This is doing the assignment of the rectangles, this for loop right here. You can turn your microphone on if you want.
I forgot that was an option.
Oh, okay, yeah.
Yeah, so I guess I don't, in terms of like locating memory, why isn't it just the for loop in which you are declaring?
Oh, instead of this?
Yeah.
Oh,
That?
so let's make sure it doesn't like that, yeah. Variable board might not have been initialized. So board itself hasn't been given a value.
Huh.
And so board bracket I doesn't make any sense. So let's think about this in terms of C, okay? Because that's why we learned C, because it lets us think about what's actually going on. Let's say we want to make an array of strings, okay? So car argv, okay, a pointer to a pointer. Argv equals malloc 8 times size of car star. All right. So what does argv look like when we do this? It's probably null. Okay. After we do this, argv is an array of pointers, right? An array of memory addresses. But you know, each of these is probably null or garbage, right? So then we would say argv bracket 0 equals malloc size of car times 6. And now this is going to point to some other block of memory where there's 6 spots, and then we could, you know, string copy argv 0 hello, and this will become HELLO null terminator. All right, so this is creating space for the collection of pointers, and then this is actually creating space for that first pointer to point to something meaningful. That's kind of what's happening with this double new business in Java, right? Saying rectangle, new rectangle bracket 8 is basically creating a spot where there can be 8 references to rectangles. And then that for loop is creating, you know, what each of those references should be, if that makes sense.
Yeah, I'm with you now.
Okay, cool. All right. Let's see. Could you do the declaration and construction on the same line? Yes. So we can definitely do this. Right, and that should work fine. All right, so that's the other way to do it. Yes, Java doesn't have automatically growing arrays by default, right? So when we construct our array like this, we're fixing it to 8. Now this 8 could be a variable, right? But if you're working with an array and you find you need a bigger array, you would need to, most straightforward way, copy the contents into a bigger array and then go from there. But this is why we use things like linked lists, for example, or other collections, because we can treat them like an array, right? We can index them with get instead of, you know, brackets, but they automatically are unbounded. So yeah, if you want something dynamic, probably go with a linked list. So let's do the two-dimensional version. So rectangle, bracket, bracket. All right, so declare a two-dimensional array of rectangles. And then we'll construct an 8x5 array, which we could also do in one step. So let's go ahead and initialize these. Let's just make an I by J rectangle. Alright, so that actually constructs 40 rectangles for us. And so this, you know, you can carry this out to any number of dimensions, but it's just board, bracket, first index, bracket, second index. So, so this array, so length or width of the rectangle, you mean? I don't remember what my arguments are for the rect. Yeah, I don't remember. We'll find out when we run it, though. But I'm just doing this just to make, you know, the rectangles different from each other. But yeah, the array is 8x5, and I'm thinking of this mentally as, you know, if I were to look at this in memory, 8 rows and 5 columns. But how it's actually laid out in memory is a totally different question. Alright, and then we'll just do a pair of nested loops to print out the values of these rectangles. This should work, except for that. How about that? So it's just variable equals, and then we're constructing a two-dimensional array of objects. Alright, so it looks like when we call our rectangle, that height goes up to 7. So yeah, the first one is the height, and the second one is the width. But that's kind of arbitrary. Alright, so there's 40 rectangles. So you'll only need a two-dimensional array for your board, right, if you do it the way that I was describing. And it's going to be basically the same thing, except making an 8x8 array of boxes instead of boards. And when you want to access, you know, a particular element, it's just, you know, the same old thing you're used to. Alright, still making sense, hopefully. Alright, so, next thing, let's look at Eclipse. I was pretty sure I was going to open this up and you're going to see all my source code for dots, so but we're good. Alright, so let's look at you know, the stuff we were playing with the other day. So we had our moving circles, and let's say you're developing your dots program in Java and you want to know if this works, you know, in the way it should for submission. So this is called cool stuff. Okay, and remember there's a workspace defined, and right now I'm working under Home, Files, Eclipse, All Workspaces. Okay, wherever you set it up to begin with, right? That's where it should be. So let me hop into that area. Files, Eclipse, All Workspaces, and there's my cool stuff. There's cool stuff. Okay. So usually when you go into your Eclipse directory, you'll see a pair of subdirectories, bin and source. Okay. If I look under bin, it's just got my class files. Okay. If I look under source, it should have my source files. So those are the ones I'm going to want to submit. Okay. So here's what I'm going to do. I'm going to make a new directory, and I'm just going to copy asterisk.java to that new directory. Okay. Don't move them. Just make copies of them. If you move them, you'll break Eclipse. So now I have a completely empty directory with nothing in it except my 2 Java files, right? Which, you know, some of it I wrote, some of it Eclipse wrote for me. You know, most of this stuff was mine. Most of the first stuff was from Eclipse. This should be runnable by just compiling and running. So I can say javac star.java and then java main cool gframe, right? And there's my executable program. So we're developing an Eclipse, but you want to make sure that you can run your program outside of Eclipse. And if you just move the .java files into a separate directory, compile everything, and then run whichever one has your public static void main, you should be able to get your program running. All right, and then this would be what I would submit to GitLab, right? So I do a git init, git add, git commit, git remote add origin, git push origin master, and we're done. All right. Hopefully that makes sense. So I want to talk about some complications in putting a panel inside a panel. Let me just start this, and we'll dig into this further tomorrow. But let me start a new Java project, and let me start a Java JFrame. And let me drop an absolute layout manager in here. Okay, so we've got our JFrame, that's the big outside area. We've got a content pane, which is a JPanel inside here. And I can resize the JFrame. When you write your PA4, you're going to have a drawing area in here. You're probably going to have, you know, some buttons and some text fields and some labels and things like that. You may not want to be drawing directly on this content pane because 0, 0 is right up here. You're going to have a dot way up in the upper left corner. Okay. And so what you may want to do is create a new JPanel and put that inside this first JPanel. And you can set that. This always slows down or crashes Eclipse the first time you do this. But you can grab the corner and make this bigger, and then you can place it wherever you want. So you could have your playing area, say, right here, and then have some buttons up on the top and an area for the score and so on and so forth. Yeah, Eclipse is struggling. So I want to look at how to set that up because the buttons and such are going to be placed in this first content pane, but this JPanel is going to be sitting somewhere else. And to connect those button events to code inside this new JPanel is going to take a little bit of work. Okay, it's not terrible, but it's something we need to do, and it's another one of these things that you'll encounter, say, in Android Studio and other GUI type development environments, where there's one object that has immediate access to, you know, the mouse listener or things like that, But there's another object that needs to interact with those widgets as well. Okay, so we'll talk about how to tie those things together tomorrow. And then I will talk about JavaDoc, because I want to show you how JavaDoc works. And then we'll go on from there. All right. Should be a layered panel or just a plain old panel. I don't actually know what to do with a layered panel, so I'm just going to make it a plain old panel once Eclipse wakes up. Allows components to overlap each other when needed and specifies each component's depth in the container. That sounds interesting. That's probably a heavier weight than we need, but I don't know. Play around with it. Tell me what you find out, because that sounds interesting. Hey, it came out of its brain lock. That's good. Alright, so now there's a panel, and I can do this kind of stuff. And I can make a text field and drop my text field here. And this is called JText field, right? But the problem is, if I put a mouse listener in here for mouse clicked, I can't get to the JText field. Okay. So anyway, we're out of time. We'll play with that tomorrow. All right. Have a good one.